What's up, Chuckles? This is Mr. Schneider coming to you from my office. Unfortunately, this thing has crashed the last two times I've tried to use it. So hopefully I can get through this video and let's dig into some example one here. So some background, the overarching way that we're going to do these problems are kind of the same that you've done for a chapter and one section 8.1. And you're going to see that as we work through example one. But we're going to change to the t-distribution. We're going to do a t-test for two samples. And if you remember from chapter 7, the reason we would do use the t-distribution is if we have small samples, and small would be less than 30. So you're going to see as we do the couple of examples that we have today, it's going to be a deal where it's less than 30. Now, in the book, if you're following on in the book, they are using critical values and rejection regions. The way we've been doing it in class is we use technology to get our p-values, and then we pit our p-values against our level of significance, make our decisions to reject the null hypothesis or fail to reject the null hypothesis. From that, so we are going to be using those methods. I know some of you kind of explored critical values and rejection regions, just another way to do it. You should get the same exact answer. So, yeah, we're going to try and go through this before it crashes again. Okay, so we're going to start with example one here, and you're going to see that it says the braking distances of eight Volkswagen GTIs and 10 Ford Focuses were tested when traveling at 60 miles per hour on dry pavement. So the results are shown at the left. The results are shown over here. Can you conclude there is a difference in the mean braking distances of the two types of cars? Our level of significance is going to be 0.01. Now, these things right here are important. Let me see if I can underline this. We're going to assume that the populations are normally distributed, because if they weren't, then we couldn't use this method. And then here's a new thing. The population variances are not equal. And I'll show you where that comes into play as we go on. It's going to come into play when we plug some things into our calculator app over here. Okay. So the first thing we need to do is, same as it ever was, we are going to set up our null and alternative hypotheses here. So our null hypothesis is going to be, let me see if I got any better from last week. Probably not, probably worse. Mu1 is equal to mu2. Mewtwo. It's like Pokemon. And my alternative hypothesis is going to be mu1 does not, no, it's a terrible mu, does not equal mu2, because our claim right here is, can you conclude that there is a difference? So a difference would indicate they are not equal. So this guy right here would be our claim. Okay. So that is our first step in this problem. Okay. So what do we do next? Well, the next thing we need to get is our p-value. What's our p-value going to be? Well, to get our p-value, we're going to plug in and run a two-sample t-test on our calculator over here. So I'm going to turn this bad boy on. I'm going to come over here to stat. I'm going to scroll over to tests, and you're going to scroll down. You're going to see two-sample t-test. Okay, so I'm going to click on that. Data, there's going to be one where you have data in your homework, so you can either use the lists or you can use one variable statistics in your calculator to get those. I'm going to hit enter right here. We're going to input stats, and we have about 30 seconds remaining. So I am going to shut her down, and we will find the p-value in our next video. So I will see you in a couple of seconds.